Hey everyone, it's Mr. Glover here. So today we're going to move on from graphing inequalities, and we're gonna learn how to solve them by hand. I think you'll find that in some cases this is easier and quicker, and in other cases it's maybe going to be a little more work. But it is an option for us whenever we don't have graphing technology. All right, so let's get started. Last class we solved systems of linear inequalities on our calculators. Now we're going to solve them by hand. We can finish the intersection points by plotting the functions, but it is time consuming and it's sometimes difficult to be exact. We can get really close to our answer, but a lot of times when you use technology, what you're doing is approximating and you're not going to get the exact answer. Since an intersection point is just the point where two equations meet, all it represents is the point where two equations have the same y value. And x value. This means that all we have to do is find the intersection points, is to set the equations equal to one another and solve for whatever variables are left. So let's say we had this system and we wanted to solve it. If we wanted to solve this, we could just say x plus 2 equals 2x. Then we could rearrange the equation and we can solve for x. We could move the x to one side, so 2 equals 2x minus x, or 2 equals x, and we've got our solution. Now that's what you'd call solving an equation or a system of equations, but what we're doing today is going to be a little different than this. We're going to be solving inequalities. So rather than finding one value for x, we're going to be solving for critical points. And then we're going to use those critical points to determine whether we need all the values above or below or between our critical points. All right, so let's take a look. Solving the following linear inequality, write your answers on a number line. So we've got minus 3x plus 2 is greater than or equal to negative 10. So let's write that over here. Minus 3x plus 2 is greater than or equal to negative 10. And now I'm going to move everything over, all the x's to one side and everything else to the other side. So I'll have minus 3x is greater than or equal to negative 10 minus 2, which is negative 12. Okay. And now I need to solve for x, so I need to divide by minus 3. The problem is when I divide by a negative, it flips the direction of my inequality. So I can divide by it, but now instead of greater than or equal to, it's less than or equal to minus 12 over minus 3. And that's just got to do with the fact that we're multiplying or dividing by a negative number. So we know that x must be less than or equal to my positive 4. And so we can draw this on a number line fairly easily. Draw our number line, we put our 0 in the middle, and then we put 4. Our answer is going to include 4, so we write a solid dot, and we can draw an arrow over to the left. When we're solving quadratic inequalities, we're going to run into some problems, and that's because you're going to often have more than one solution. And so if you have more than one solution, you don't always know if you need to be less than one or less than the other. Do we need to be between those two? So we can solve the equations using factoring or using the quadratic formula. We can find our critical points, but we're going to have to actually test some points to see which range of values our solution falls under. So this is the approach we're going to take. We're going to factor the equation if possible. If not, we could use the quadratic formula. Draw a number line with the critical values labeled. We're then going to split the number line into sections based on what the critical values are. And so, for example, like if we had, let's say we had 2 critical values. We had one at minus 1 and one at 2. We basically have 3 segments. We've got A, B, and C. A is going to be minus infinity all the way to negative 1. B is between minus 1 and 2. And C is going to be above 2. And then we would have to go and test some answers from each set to see which one is our actual solution set. The other thing we're going to do is we're going to talk about a new method for writing down intervals rather than using a number line every time. We can use what's called interval notation. And interval notation is kind of tricky, and it's quite nitpicky, to be honest. The shape of the brackets means something different. So if you use curly or rounded brackets like this, curved brackets, those are what you call an open interval. And what that means is that the outer ends of your set, so like A is going to be the lowest number in the set, B is going to be the highest number in the set, those are not actually part of it. Those just sort of denote the place where you cut the numbers off. If you write square brackets, then A and B are part of the solution. So it's kind of nitpicky and it's kind of finicky, but it makes a difference. So if I was to write something like -3 with a rounded bracket, comma 5 with a square bracket, what that means is that -3 is the low point, but we're not including that number. So like -2.9 would count. -3 doesn't. 5 is the highest point, but 5 is included in our set. And then one other thing to be a little bit careful with is that plus or minus infinity is always written with curly brackets or curved brackets, because it's not actually part of the solution. It's a way of saying all numbers below this point, all the way to negative infinity. But negative infinity itself isn't a number. It's more of a concept. So we can't really actually include that number in our range. So you need to use curly brackets in that case. All right, so let's try this out. We've got a system to solve. We're going to have to factor this equation. We're going to find our critical points, and then we're going to use our critical points to figure out what our actual solution set is. Okay, so we're going to need some space. Let's zoom in a little bit, and let's rewrite the equation out. 2x squared minus 5x plus 1 is less than or equal to 4. There's our equation. I'm going to move everything over to one side. So I'm going to subtract the 4. And I'm going to get 2x squared minus 5x minus 3 is less than or equal to 0. Okay. And now at this point, we can kind of scrap the less than or equals to sign. It doesn't really matter. You can keep it there. But we just have to factor this. So we can write out an equation that matches, and we can factor that equation. So let's just go 2x squared minus 5x minus 3 equals 0. We're going to use that to find our critical points. Now we have to factor it, and unfortunately it's one of our ugly type of factoring problems. So we have to take the 2 and multiply it by -3 to get -6. We can list our factors of -6, so there's going to be like 1 and 6, 2 and 3. And then we need to figure out which pair of these is going to match up. It needs to add to -5, and it needs to multiply to -6. I think -6 and +1 will fit the bill. -6 plus 1 is -5. -6 times 1 is -6, and that's going to work. So we need to split the middle term up now. So 2x squared minus 6x plus x minus 3 equals 0. I've just gone and taken 5 and split it into -6 plus 1. And now we can put our brackets in, and we can go ahead and factor this. We can remove 2x from the first set of brackets. So 2x times x minus 3 plus 1 times x minus 3 equals 0. And lo and behold, this is factored as 2x plus 1 times x minus 3 equals 0. And so now that we've done all of this, what we've actually found is we've found our critical points. So the critical points are where our brackets are 0. This first bracket is 0 when x is -1/2. So our critical points, x equals -1/2, or x equals +3. That's because +3 minus 3 is 0. All right, so we've kind of done the hard work now. Now what we have to do is put this on a number line, set intervals up, and then test a number from each one to see where our solution actually is. So let's go back up here. Draw our number line. We're going to split the number line into sections now. So -1/2 is one of our critical points. The other critical point is the point 3. All right, and then the number line, I guess, can keep going. So we're going to have 3 intervals. And I'm going to write the intervals. Let's use blue. We could go from -infinity up to -1/2. we won't include minus 1/2 in this interval, so let's go, or we will include it, but we can't include minus infinity. The middle interval is going to be from minus 1/2 to 3, so minus 1/2 to 3, and I'll use the square brackets because they can be included. We've got a less than or equal to sign. And then our last interval is going to be from 3 up to positive infinity. Okay, so we need to test 3 different ranges. We could call it interval 1, 2, or 3. So let's test one out. Let's test one from minus infinity to negative 1/2. So we're going minus infinity to negative 1/2. I'm going to test the point minus 1 because it's going to be fairly easy for me to calculate those numbers. So we're using this equation, but I'm going to replace x with minus 1. So 2 times minus 1 squared minus 5 times minus 1 plus 1 must be less than or equal to 4. 2 times minus 1 squared is just going to be 2, and then minus 5 times minus 1 is plus 5 plus 1 must be less than or equal to 4. I get 8 is less than or equal to 4, but that doesn't work. So this solution is out. Let's try the middle tier. Let's go minus 1/2 to 3. I'm going to test the point 1 because, again, multiplying with 1s is fairly easy to do. So 2 times 1 squared minus 5 times 1 plus 1 must be less than or equal to 4. This gives me 2 minus 5 plus 1 is less than or equal to 4. And I get negative 2 is less than or equal to 4. That works. So it looks like this is my solution range. But we'll test the last one just in case. So from 3 to infinity, we don't have a nice number to pick, so we can let's just test 4, I guess. So we can go 2 times 4 squared minus 5 times 4 plus 1 must be less than or equal to 4. 4 squared is 16, times 2 is 32, minus 20 plus 1 is less than or equal to 4. And we're going to see that this does not work. We're going to get 11 is less than or equal to 4. So this range of values doesn't work. So what we actually have as our answer is this one. This is the only one that actually works out. And so our final answer is going to be x must be between minus 1/2 and 3. So that's quite a process. It's not that easy to do. We have to factor the function, find the critical points, put the critical points on a number line, split it up into sections, and then test a number from each section to see what the solution is. I would probably rather use a graphing calculator for this if it's available to me, but I know that there's some times when you don't have one and you need to know to do it by hand. Normally, this would be something that I would ask you to do on a test, but right now that's not our reality. Let's try another one of these. So we've got 5x squared plus 6x minus 1 is greater than 7. So let's write that over here. 5x squared plus 6x minus 1 is greater than 7. Okay, I'm going to move the 7 over by subtracting it, and I'll get 5x squared plus 6x minus 8 is greater than 0. All right. And now I'm just going to replace this with an equals sign. So let's use a different color just to symbolize that we're just finding critical points. So 5x squared plus 6x minus 8 equals 0. So now we've got to factor this. We take our 5 and take our minus 8, multiply them together, and we end up with minus 40. And now we need to start listing some factors. So there will be 1 and 40, 2 and 20. There won't be 3, but there's 4 and 10. And I guess there's 5 and 8, and I think we can stop here. We need a combination that's 6 apart. It needs to add to positive 6 and multiply to minus 40. I think minus 4 and 10 is going to fit the bill. And the reason why is they're 6 apart. 10 minus 4 is 6, but 10 times minus 4 is minus 40. So This should work. We can now write, we can split the middle term up. So let's go 5x squared minus 4x plus 10x minus 8 equals 0. And remember, I like to put the negative sign first because then I don't run into problems when I throw brackets around each term. And now we just have to factor what we can out. This one, all we're going to be able to factor is an x. So we can go x times 5x minus 4. And this one, we're going to be able to factor out a 2. Our goal, again, is to make these brackets the same. Now that we have it written like this, we can finish factoring. So x plus 2 times 5x minus 4 equals 0. And we've got our critical points. The first one is 0 when x equals minus 2. So critical points, x equals negative 2. And the second one is going to be 0 when x equals 4 over 5. And now if you can't do that one in your head, you can always set this equation equal to 0, move the 4 over, and then divide by 5, and you'll get 4/5. All right, so we've got our critical points. First part is done, the hard part's done. What we have to now do is we have to go and write the number line and split it into sections. So we've got critical points at minus 2 and 4/5. 0 is probably in the middle. This is not very nicely drawn to scale. All right, so we've got 3 sections. We've got from negative infinity up to 2, or up to minus 2. And now because we're exclusively greater than, minus 2 is not actually included in our set. So I'm just going to put rounded brackets. The middle portion would go from minus 2 up to 4/5, which again, we have to put the brackets that are curved because they're not included. And then the last section is going to be from 4/5 up to infinity. So we've got 3 to test. All right, let's test the first one out. Let's use a different color here. Let's use, what do we use above? Blue? We'll stick with blue. All right, so we're going to test from minus infinity up to 2, or up to minus 2. Let's pick, I don't know, let's pick minus 3. So 5 times minus 3 squared plus 6 times minus 3 minus 1 must be greater than 7, okay? So now minus 3 squared, that's just going to be 9. So 5 times 9 plus 6 times minus 3 is going to be minus 18. Minus 1 is greater than 7. 5 times 9 is going to be 45. Minus 18 minus 1 is greater than 7. 45 minus 19 is greater than 7. And we'll get 26 is greater than, or sorry, what am I doing here? 26 is greater than 7. This looks like it works. Okay, let's go test our middle one now. So let's test the outer, or the middle portion. So from minus 2 to 4/5. I'm going to test 0 because 0 is an easy number to do. So let's go 5 times 0 squared plus 6 times 0 minus 1. This needs to be greater than 7. First term is 0. Second term is 0. Minus 1 is greater than 7. And it looks like we have minus 1 is greater than 7, which doesn't work. So this range is out. Now we get to test our other range. And that's going to be from 4/5 to infinity. I believe that's it. Yeah, 4/5 to infinity. Now let's just pick 1 because 1 is a nice number to work with. So 5 times 1 squared plus 6 times 1 minus 1 is greater than 7. We get 5 plus 6 minus 1 is greater than or equal to 7. Or sorry, it's exclusively greater than 7. 5 plus 6 minus 1 is going to get us 10 is greater than, whoops, just greater than 7, which works. And so putting this all together, we've got two portions that work. We've got this portion over here that works and this portion over here that works. So our answer is going to be two different ranges of values. We were going to have minus infinity to minus 2, or 4/5 to infinity. And now this is kind of weird. This is something that's different than we've seen before. We've got two ranges of values that work, and it seems kind of strange, but it actually makes a lot of sense. So I'm going to switch over to another screen for a second here. If you graph parabolas, so quadratic functions, they always have this parabolic shape. They're always going to look like this. And now they might be upside down, but it doesn't really matter, okay? The point is that you're most of the time going to have two critical points, right? And now your solution is either going to be the points above, because they're going to be the points to the left and to the right, or your solution is going to be this middle part. So when you have a quadratic function, unless you've got a special case where it doesn't actually touch the x-axis and has no solution, or maybe it touches in one spot, you're always going to have two critical points, and the number line is always going to have these two values. So you are either going to have an answer that looks like this, or you're going to have an answer that's in the middle and it looks like this. That's just based on what a parabola looks like. So it makes sense that we've got one range over here and one range over here. Where are we? All right, let's try one more question. NPSS is trying to make some money for student council by selling spiritware. The formula, R as a function of n equals 40n minus 0.1n squared, can be used to determine the revenue R based on the number of sales n. Mr. Pauls decides that we need to make $3,000 in revenue in order to host a pep rally. Determine the interval for the number of sales that need to be made. Okay, so we've got this function. R as a function of n equals 40n minus 0.1n squared. We know that the revenue R is going to be how much money we make, and n is going to be the number of sales we make, okay? And now you might think, well, the more sales you make, the better. But in this case, it might not work out that way. There might be like a sweet spot where if we sell a certain amount, we're going to hit our goal. And maybe if we go past that, then maybe more expenses become a factor. We also know that we need to make at least $3,000 in revenue, okay? So what I know is that $3,000 is less than or equal to 40n minus 0.1n squared. And that's because we need to make at least 3,000. This function needs to be greater than or equal to $3,000. All right, so we can now move things around and we can rearrange this equation. We can move the 0.1 to the other side by adding. We can subtract 40n, and we're going to get the equation. I'm just going to zoom in a little bit here. We're going to get the equation minus 0.1n squared, or sorry, plus 0.1n squared minus 40n plus 3,000 is less than or equal to 0. Okay. And now, now that we have this, we have the starting point of a question that we just did. It's just got some ugly looking numbers, unfortunately. Now, I don't want to factor something with 0.1 as my leading coefficient, so I'm going to remove it. I'm going to factor it out, 0.1. When you divide by 0.1, it's like multiplying by 10. So this is going to become n squared minus 400n plus 30,000 is less than or equal to 0. And now technically we can kind of get rid of this 0.1 because 0 is on the other side, and if you divide 0 by anything, it's still 0. So we actually can have the equation n squared minus 400n plus 30,000 is less than or equal to 0. Now, I'm going to just change this to an equal sign because now we can go about factoring it. So n squared minus 400n plus 30,000 equals 0. You can skip this part if you want, keep it like this. And now it's going to be kind of ugly to factor this. We need to think of two numbers that are going to multiply to 30,000 and add to minus 400, and it seems kind of weird. But if you think about it, 300 times 100 gets us to 30,000. Minus 300 plus minus 100 is minus 400. And so we can just use those numbers. We can go n minus 400 times n minus 300. What am I saying? 300 and minus 100 equals 0. 300 times, or minus 300 times minus 100 is positive 30,000. Minus 300 plus minus 100 is minus 400. So this will work. So we have our critical points now. Critical points are when n equals 300 or n equals 100. All right. So now we can go ahead and we can write our number line out. The number line is 0 is going to be over here, but let's just go 300 here, or 100 there, 300 on the other side. And we've got three distinct regions. We've got minus infinity, although technically you can't sell negatives of something, so let's keep the context as part of the problem. So we've got it from 0 to 100, and we have less than or equals to, so these could be included. We have 100 to 300. And we have 300 to infinity. So we need to go and test these points, test a number from each one, and we need to figure out which regions or region is our solution set. So let's do the first one, from 0 to 100. Now, I like using small numbers, so let's use 0 or 1. We've got our equation. What's our equation again? It's 3,000 must be less than or equal to 40n. Let's just use 1 minus 0.1 n squared. So let's use 1 squared. All right. So 3,000 is less than or equal to 40 minus 0.1, or 3,000 is less than or equal to 39.9. That's not true, so this does not work. Okay, now right off the bat, I'm not saying that this is always going to be the case, but because this region doesn't work, I'm going to say it's pretty unlikely that this one's going to work, because normally we either get both outsides or we get in between them. And so I'm going to guess right now that this is going to be our answer range, but we can test them all. That's the better strategy to do. So from 100 to 300. I need to pick a number. Let's go, it doesn't really matter. Let's do 150. 3,000 is less than or equal to 40 times 150 minus 0.1 times 150 squared. And now you can do this by hand, but I'm gonna type it into a calculator and do it that way, do it in one shot. So 40 times 150 minus 0.1 times 150 squared gets me 3,750. So 3,000 is less than or equal to 3,750. That is true, and this does work. So this portion is gonna be part of our answer set. Then the last question is what about above this critical value? Well, we can test that out. So let's go from 300 to infinity. Nope, too many 300s included, infinity is not. So 3,000 must be less than or equal to 40 times n. So let's use 400. 40 times 400 minus 0.1 times 400 squared. Put that in a calculator. And I get 0. That is not true. So this is not part of our solution set. So if we look back at what we've done, we found a range of values or we found our critical points. We've split the number line into sections. We've tested each section, and we found that only this middle portion contains answers that work. So that's our answer. X is going to have to fall in this range. So from 100 to 300. And now technically we're doing a word problem, so we should actually apply some context to this. Sales need to be between 100 and 300 to make at least $3,000. And there we go. So this is a section that we're basically drawing upon skills that we already have and kind of extending them into these inequalities. It's a little bit different, but you've all got the ability to actually find your critical points. It's then what you do with those critical points. How do you interpret your answers? That's what this section is all about. So I've got some questions for you to try. Page 372, number 3, 4, 5 to 7. These starred questions over here, those, I'm not going to say they're bonus, but they're just extra questions. They're not required. They're not something I need you to do, but they're definitely something that's worth doing. And if you've got the time, I would suggest you try these problems. But I'm trying to keep the assignments manageable for now. So that's where I'm going to end things now. I hope everybody has a great rest of the day, and I will see you all tomorrow in our chat. Bye for now.